Welcome back to NeuralTensors. Today I'm super excited to share an AI-powered CSV analysis tool that runs entirely locally on your machine. No cloud, no external APIs. It uses DeepSeek R1 1.5 billion model via Ollama along with LangChain and FAISS for vector search. Let me quickly show you a demo. Here we upload any CSV file and then get instantly data summaries and insights. And then the cool part that you can ask questions with local LLM about your dataset. Everything you search just happens locally. The AI is running entirely on your device. The project is organized into a clean modular structure. app.py is our main Streamlit application, and datautils.py handles data loading and insight generation. And AIutils.py, this takes care of embeddings, vector search, and setting up the local LLM. Requirements.txt, it lists all the Python dependencies, and a sample CSV for testing purpose. Now let's see how the workflow comes together. So here's the project workflow. First we have CSV upload, then load CSV with pandas into data frame, and then generate data insights, convert insights to LangChain document objects, and then create embeddings, and then we store embeddings in FAISS vector store, and then set up LangChain retriever from FAISS, configure local LLM, create retrieval QA chain, then we have user query input, retrieve the relevant insights, and then pass query plus retrieve documents to LLM, and then generate AI response, and finally display response. To run this project, you'll need Python 3.9 or newer, and then Streamlit, Pandas, LangChain, FAISS, and then Ollama with DeepSeek R1 1.5 billion model installed locally. You can install everything using the requirement.txt file. From the terminal, just type the command pip install -r requirements.txt. Now let's take a closer look at the actual modules and the functions powering this system. Here under datautils.py, there we have data overview function. This gets total rows and columns, and it lists column names with data types, calculates missing values, count and their percentage for each column. Numeric stats function, this identifies numerical columns, and for each columns it counts total null values, mean, max, and mean, median, and standard deviation, and returns each as a string summary in a list. And then categorical stats function, this identifies categorical columns, and for each column it finds the number of unique categories, most frequent category, that is mode, then top 5 frequent values with their counts and percentage, returns each as a string summary in a list. And the correlation summary function, and it is used for if there's more than one numerical column, it computes correlation matrix and finds a pair of columns with highest positive correlation and highest negative correlation, and again returns both as a string summary. And then we have AIutils.py. Here the function create documents, this converts each text insight into a LangChain document object, and create vector db, this creates text embeddings for each document using Ollama embeddings loaded with DeepSeek R1, and stores embeddings inside of FAISS vector database for similarity search. And then the function setup QA chain, this creates a retriever object from FAISS database, loads LLM via Ollama, and constructs a retrieval QA chain using LangChain, and the query will pass through the retriever, and then it gets top 5 similar insight documents, and retrieved insights plus query are passed to LLM. Then LLM generates a natural language response. And then we have app.py, sets up streamlit UI, page title, layout, and file uploader to accept a CSV. When the CSV is uploaded, temporarily saves the uploaded file to the disk using temp file and loads CSV into pandas data frame. It displays top 5 rows using st.dataframe. And for insight generation, it calls dataset overview function for basic shape, column types, and missing values from data utils. And also it calls numerical stats, categorical stats, and correlation summary function from datautils.py. And it combines all insight into a list of text summaries, concatenates into a full summary text, and adds this summary text back to the insights list for later querying. And calls create documents from AI utils, also calls create vector db function, and then set up QA chain. And if query is for summary or all insights, directly shows the full summary, else it passes query to QA chain.run for AI generated response and displays AI response. And that's it, a fully local AI powered CSV data assistant you can run on your machine, private, offline, and easy to extend. If you enjoyed this, make sure to check out GitHub repo. Link is available in the description. I'll be sharing more local AI projects soon. Don't forget to like, subscribe, and turn on notifications. Thanks for watching. See you in the next video.